Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. We are from International Program on Science Education 2019. Today we would like to present our final project. So our courses is Integrated Science and we are from Group 4, consists of me, Nimas Ayu L, and my friends Rahma Hanifa and Hesti Husnul K, and the last is Ilfa Qurrota A. Okay, let's watch our final project. The topic for our project is Simple Machine. Simple Machine is any mechanical device that changes the direction or the magnitude of a force, and simple machines allow someone to do work for faster and better. There are 6 types of simple machine. There are lever, inclined plane, pulleys, wheel, axle, and the last is gear. Our project is to design catapult with strong construction, and also our catapult can throw the tennis ball farthest.
The next topic is the relationship between the project and the topic. So, most of the machines that we use today are made up of the combination of the different types of simple machine, and our project is the example of that. We use the principle of a lever. The lever can be made by balancing board on the log, pushing down on the end of the board and lifts on the other end of the board. The downward force you apply is the input force and the upward force on the board except on the load is the output force. The distance between the input force and the fulcrum is the power arm, while the distance between the load and the fulcrum is called by load arms. The next is how we design our catapult. We created our catapult design with one side that heavier, so when the other side is we apply the force on the other side, we and then we release the force. The catapult will return to its original position, so it can throw the ball. And the shape of the catapult that we made is so much like the 3x catapult, but we made some modification. We not use the rod to throw the ball, but we directly put the ball in the end of the catapult. So we're taking the advantage of the weight and the height to throw the ball, the tennis ball. So what is the tools and the materials that we need? The first is 5 pieces of wood with long 70 centimeters, and then 2 pieces of wood with long 60 centimeters, and then 3 pieces of wood with 30 centimeters, and then we need wooden plank with the size 20 times 20 centimeters, and the other wooden planks with the size 15 times 20 centimeters. And the next material that we need is iron woods with the long but 30 centimeters long. And the other things that we need is nails, and then plastic containers, and then rubber tires, and also the tennis ball, and then the stone, and the next is small bucket, and the last is hammer.
For the novelty of our project, we use concept of first class of lever and also use the concept of trebuchet catapult, but we made some modification. We didn't use the rope at the end of power arm to throw the ball, but we manually throw the ball by utilizing the weight and the height. In this way, we can adjust the distance of the thrown ball. And here is the place of the load, the fulcrum, and the applied force of our design. Here is our initial design. We take picture from different side. Now also here is the different side also. As we can see in these pictures, the ratio of the load arm and the power arm is not very big. So yeah, here is our initial design.
This is our initial project. As you can see, this catapult cannot throw the ball far. This happened because the load that is installed is less heavy, and the power arm is too long. In initial project, the ball reached the highest point at 1.2 meters, and a distance about 1 meters.
So for the next, I will explain you about the initial design. So what is the weakness and what we revise from our initial design. So firstly, it's about the weakness. The weakness from our catapult is the distance. The distance from the catapult is too short. As you can see from our initial video, our catapult can only throw the tennis ball about 1 meter, and the catapult cannot reach the farthest distance. So we already revised it. How we revise it? It's by 3 steps. First is by cut the wood on the load arms, and the second one is by adding a tire strap, and the third one is by adding stone as a load. So why we use this step to revise our catapult as is based on mechanical advantage of lever formula. So the formula is about mechanical advantage. Mechanical advantage is the ratio of the output force divided by the input force. It means that if mechanical advantage is more than 1, that the output force is bigger than the input force. Simply say, if you want a bigger output force, you need a bigger mechanical advantage. So in this, you can see that mechanical advantage is equal to weight or load divided by the force or effort. So the load is directly proportional with the mechanical advantage. So if you want a bigger mechanical advantage, you need a bigger weight. So in this case, we use a bigger stone as a load. And also from this formula, we know that mechanical advantage is equal to force arms divided by the load arms. So mechanical advantage is directly proportional with the force arms. It means that you need to extend the length of the force arms, and mechanical advantage is inversely proportional with the load arms. It means you need to shorten your load arms, and we already applied it from our final design. So this is our final design. As the photo is the different side of photo. In the first side, you can see that we cut a rest of the load arms and we maximize the distance of our effort arms. And in the middle, you can see that we use a bigger stone as the load. And this is the other photo. You use the tire strap so it can hold the wood as the force arm, so it can rotate and it will stay in the initial place.
And this is our catapult after we revised it. We cut the power arm and added some stone to make the load heavier. Other than that, we put some rubber band above the fulcrum so the ball is thrown farther away. In the final project, the ball reached its highest point at 1.5 meters and a distance about 4 meters.